When you develop a theory in physics, it has to be in connection with experiments. That's typically the case. Now, does it have to be? No. For instance, string theory is in the theoretical world, because so far we're not going to be able to do experiments directly on, say, strings. It's essentially an entirely theoretical result. Is that useful? Yes. In physics, it's important to have these things. Now, if it's completely always disconnected from experiments, then one should question the merits of it. If you have a theory that has no experimental evidence or very little, then you should be cautious of that. If you are developing a theory, one of the things that has to be true, it has to be mathematically correct. If you're developing a theory and it has logical inconsistencies, that's not good. The other part to make sure it's actually correct is to see what the experimental evidence is. And if it's so far, you can only get to a certain aspect of the theory and the experimental results are so far, that's okay. And you can leave it and then let a few years and decades pass till the experiments are ready to catch up to that. The Higgs particle, for instance, is a theoretical result that they came up with. It was many years where the theoretical result was there, but only later did the experimental evidence come along. You can always see if a theory is correct. Again, is it mathematically consistent? Does it match the experimental results? If there's a theory that does not match the experimental results, then yeah, you should discard it. After, of course, doing your due diligence, you check, okay, is the experimental result correct? Are we very confident? And there's repeated experiments that show this theory is not correct, then you should discard it. What's an example of that is the idea of the ether, that there is a substance through which electromagnetic waves goes through. That was an idea. Why? Because a lot of the waves that you know of, almost all of them, require a medium to go through. So sound, the fact that I can talk to you is because there's waves that are generated within the medium, which is air. So the air is vibrating and then that information is what travels. And so the idea there was, oh, for light to travel, there should be some medium through which it goes through. And it turns out, experiment after experiment, that's not true. Light doesn't need a medium. It just requires space. Electromagnetic waves can travel through space without anything to go through other than space itself. When it comes to theory and experiment, it's something that has to work together. You can always think about a theory being correct or incorrect. It's not that people get to make up whatever they want in the theoretical world. When you're doing theoretical physics, it's bounded by certain things. There's some creativity involved. You want to be creative and think of interesting ways to explain something, but it's still bounded to reality.